The Generative AI Tech Stack, Building the Future of AI Applications. Introduction. The generative AI revolution is transforming how we create, interact with, and deploy artificial intelligence systems. From generating human-like text to creating stunning images, writing code, and composing music, GenAI systems are capable of producing entirely new content by learning intricate patterns from vast datasets. Building robust GenAI applications requires a sophisticated tech stack that spans from foundational cloud infrastructure to advanced safety mechanisms. This comprehensive guide explores the 9 essential layers of the generative AI tech stack, providing you with a roadmap to understand, build, and deploy cutting-edge AI solutions. Understanding the GenAI tech stack architecture. The GenAI tech stack is structured as a pyramid, with each layer building upon the previous one to create a comprehensive ecosystem for AI development and deployment. Let's explore each layer from the foundation up, understanding how they work together to power the next generation of AI applications. Layer 1. Cloud hosting and inference, the foundation. At the base of our pyramid lies the cloud hosting and inference layer, the critical infrastructure that powers all GenAI operations. This foundational layer provides the computational muscle needed to run sophisticated AI workloads at scale. Major cloud providers. Amazon Web Services. EC2 instances, specialized GPU instances P4, P3, and G4 optimized for AI workloads. SageMaker, end-to-end machine learning platform for model training and deployment. Bedrock, managed service for accessing foundational models via APIs. Inferentia, custom AI chips designed for high-performance inference. Google Cloud Platform, GCP. Compute Engine, GPU-accelerated virtual machines for AI workloads. Vertex AI, unified ML platform for model development and deployment. TPUs, Google specialized AI accelerators. AI Platform, managed services for ML model hosting and serving. Microsoft Azure, Azure ML, comprehensive ML lifecycle management. Cognitive Services, pre-built AI APIs for common tasks. Azure OpenAI Service, access to OpenAI models through Azure infrastructure. GPU-optimized VMs, high-performance computing for AI. NVIDIA, DGX Systems, purpose-built AI supercomputers. A100 and H100 GPUs, industry-leading AI accelerators. CUDA Platform, parallel computing platform for GPU acceleration. Triton Inference Server, optimized inference serving solution. Infrastructure considerations, scalability. Cloud platforms provide auto-scaling capabilities to handle varying workloads, from development experiments to production-scale deployments serving millions of users. Cost optimization. Pay-as-you-go models allow organizations to optimize costs by scaling resources based on actual usage patterns. Global reach. Distributed data centers enable low-latency inference serving users worldwide. Security. Enterprise-grade security features protect sensitive AI models and data throughout the inference pipeline. Layer 2. Foundational models, the AI brains. The foundational models layer represents the core intelligence of GenAI systems. These are massive neural networks trained on enormous datasets, forming the foundation for all specialized AI applications. Leading foundational models. OpenAI family. GPT-4, advanced language model with multimodal capabilities. GPT 3.5, efficient language model for various text tasks. DALL-E, image generation from text descriptions. Codex, specialized for code generation and programming tasks. Anthropic Claude, Claude 3, family of models, Haiku, Sonnet, Opus, with different capabilities. Constitutional AI, built with safety and helpfulness principles. Long context, capable of processing very long documents. Reasoning, strong analytical and logical reasoning. MetaLlama, LLaMA. LLaMA2, open source large language model. CodeLlama, specialized for code generation. Community-driven, extensive ecosystem of fine-tuned variants. Research-friendly, accessible for academic and research purposes. Google Gemini, multimodal, native support for text, images, and code. Gemini Ultra, most capable model in the family. Integration, deep integration with Google's ecosystem. Efficiency, optimized for various deployment scenarios. Mistral AI, European AI, privacy-focused European alternative. Efficient architecture, optimized for performance and cost. Multilingual, strong support for multiple languages. Open source, community-accessible models. DeepSeek, specialized models, focus on code and reasoning tasks. Efficient training, innovative training methodologies. Performance, competitive results with efficient resource usage. Research-oriented, strong focus on advancing AI capabilities. Model characteristics. Training scale. These models are trained on hundreds of billions to trillions of parameters, requiring massive computational resources and carefully curated datasets. Emergent abilities. As models scale, they develop unexpected capabilities like few-shot learning, reasoning, and creative problem-solving. Transfer learning. Foundation models can be adapted for specific tasks through fine-tuning, making them versatile building blocks. Multimodal capabilities. Modern foundation models can process and generate multiple types of content from text to images to code. Layer 3, frameworks, the development tools. The frameworks layer provides the essential tools and libraries that make AI development accessible and efficient. These frameworks abstract complex AI operations into user-friendly interfaces. Core frameworks, LangChain, chain building, create complex AI workflows by chaining multiple components. Memory management, handle conversation context and long-term memory. Integration hub, connect to various LLMs, databases, and external tools. Agent framework, build autonomous AI agents that can use tools and make decisions. PyTorch, deep learning, flexible framework for building neural networks. Dynamic graphs, intuitive model development with dynamic computation graphs. Research-friendly, preferred by researchers for experimental work. Production-ready, Torch script enables deployment optimization. Hugging Face transformers, model hub, access to thousands of pre-trained models. Easy integration, simple APIs for using state-of-the-art models. Community, vibrant ecosystem of contributors and models. Multi-framework, support for PyTorch, TensorFlow, and JAX. TensorFlow, production-focused, optimized for large-scale deployment. TensorFlow serving, efficient model serving infrastructure. Ecosystem, comprehensive suite of tools and libraries. Mobile and edge, TensorFlow Lite for mobile and edge deployment. Development benefits, rapid prototyping. Frameworks enable quick experimentation with different models and approaches. Best practices, built-in implementations of proven patterns and architectures. Community support. Large communities provide tutorials, examples, and troubleshooting help. Production pipeline. Smooth transition from development to production. Layer 4, databases and orchestration. The memory and logic. The databases and orchestration layer manages the complex data operations and workflow coordination essential for sophisticated AI applications. Vector databases. Pinecone, managed service, fully managed vector database with automatic scaling. High performance, optimized for fast similarity search at scale. Easy integration, simple APIs for embedding storage and retrieval. Hybrid search, combines vector and metadata filtering. Weaviate, open source, self-hostable vector database. GraphQL API, intuitive query interface for complex searches. Modular, extensible with custom modules and transformers. Real-time, support for real-time data ingestion and updates. ChromaDB, lightweight, easy-to-use embedded vector database. Developer-friendly, simple Python API for quick prototyping. Open source, community-driven development. Flexible, support for various embedding models. Orchestration tools, Llama Index, data ingestion, efficient loading and processing of various data sources. Index management, optimized data structures for retrieval. Query engines, sophisticated querying capabilities. Integration, seamless connection with LLMs and vector databases. LangChain, orchestration. Workflow management, complex AI workflow orchestration. Memory systems, persistent and contextual memory management. Tool integration, connect AI agents with external tools and APIs. Chain composition, build sophisticated AI applications from simple components. Orchestration benefits, data management, efficient handling of large-scale data operations for AI applications. Retrieval optimization, fast and accurate retrieval of relevant information for AI context. Workflow automation, automated coordination of complex AI processes and decision-making. Scalability, handle growing data volumes and user requests efficiently. Layer 5, fine-tuning, specialization and customization. The fine-tuning layer enables customization of foundation models for specific tasks, domains, or organizational needs. This layer transforms general-purpose AI into specialized solutions. Fine-tuning platforms, weights and biases, W&B. Experiment tracking, comprehensive logging and visualization of training runs. Hyperparameter optimization, automated tuning of model parameters. Model registry, centralized management of model versions. Collaboration, team-based model development and sharing. OctoML, model optimization, automated optimization for different deployment targets. Hardware acceleration, efficient utilization of various hardware platforms. Deployment pipeline, streamlined path from training to production. Performance monitoring, real-time monitoring of model performance. Hugging Face fine-tuning. AutoTrain, no-code fine-tuning for various tasks. Model sharing, easy sharing and versioning of fine-tuned models. Dataset Hub, access to curated datasets for training. Inference endpoints, managed hosting for fine-tuned models. Fine-tuning approaches, task-specific fine-tuning, adapting models for specific applications like customer service, legal document analysis, or medical diagnosis. Domain adaptation, training models on domain-specific data to improve performance in specialized fields. Instruction tuning, teaching models to follow specific instructions and formats. Parametric efficient fine-tuning, techniques like LoRa that require minimal computational resources. Benefits of fine-tuning, improved performance. Specialized models often perform better than general-purpose models on specific tasks. Reduced costs. Smaller, fine-tuned models can be more cost-effective than large general models. Customization. Tailor AI behavior to match organizational needs and preferences. Competitive advantage. Develop unique AI capabilities that differentiate products and services. Layer 6, Embeddings and Labeling, the semantic bridge. The embeddings and labeling layer transforms